I have a program that lets me explore down. So tree level 2. These were data types collections. So cd data types collections advanced nested collections. Cool. So we're doing nesting and nesting test.rb. Well, nesting test.rb. We'll open up the current directory there. And here we go. I'm going to toggle away the sidebar because I'm not going to need that, and screen real estate is small. Cool. Okay, so the intent is to work with nested collections. I haven't done any other nested collections videos. This is like the advanced one, but if you're working through these, this video should be helpful. Several things to get here. One, I have already done 2 of these exercises. Someone at Turing had reached out, they were stuck on something, and I looked at these and I was like, man, this is complex, let me play around with it. So I've done 2 of these, but I haven't done more. I'm going to rebuild the whole thing through the same process. But it's less, in my mind, I could be wrong, but it's less about knowing like, oh, I'm going to use like the dig command or something, and like process matters more. So hopefully watching me, it's going to be a struggle on some of these. Watching me struggle through some of these will be useful with showing you ways that you can maybe make small assumptions and then kind of test or validate those assumptions and then iterate from there. Programming is about taking big problems and turning them into tiny, like many tiny little problems and then rolling through those. So the process will be as important as like whatever the actual right answer is. Lastly, I don't expect, like when I get a test to work, I'm going to continue on, but I would expect that there's a lot of different ways to do all of these. And I would love to find better answers to these than the ones that I come up with. So if you work through these and you think you have a better answer or you just want insights or whatever, reach out. Let's chat. Yeah, okay. So intent, practice with nested collections. Some tests will pass without any enumeration. Others will require more complex iteration over multiple portions of the nested collection. We can use each, complete all tests using only each, then go back and refactor it using a different enumerable. The collection is stores. So this thing right here is the data that we're going to be working with over here. So let's unskip the first one and see what, well, I guess first let's run the tests empty. On Atom, if you hit Shift Control, I think it's Shift Control C, it Shift copy to copy relative. It copies the relative path. So you can also click this. If I click it, it copies the absolute path. If I shift click it, it copies the relative path. So I use this all the time if I need to run tests or like access this directory. So I can do Ruby and then paste what's on the clipboard, hit enter, and we've got a bunch of skips. Great. Unskip that. Run it again. Still passes. Great. So employees, stores, Olive Garden's employees. You should be curious, so I'm going to stick a binding right here and see what kind of stuff this looks like. So it's saying stores is like, a first question is like, what the heck is this stores object? So we'll just say stores, and that looks like a big hash that, surprise, surprise, maps to this. Make that a little smaller. So they called employees equals stores, Olive Garden employees. So usually when dealing with a hash, I just build it up slowly. So I want to see what stores, what do they have? Olive Garden. Olive Garden is stores Olive Garden. I spelled it wrong. Garden. Cool. So that is, we said stores Olive Garden, so that's pulling back this object, and Denny's and whatnot is ignored. So they called stores Olive Garden employees. So stores, I'm going to hit the up arrow, bring it back, Olive Garden employees. Great. If you haven't dealt with hashes before, by the way, there's other hashes exercises that you should start with. You can access hashes with key value pairs and symbols and whatnot. So those are the employees. So they said employees is equal to that, and then that's employees, and that works. Great. Let's carry. Pancake ingredients equals your code here. So we'll uncomment that, delete that. I'm just gonna put a pry here, and we already did all that, but the recording failed, so we're redoing it. So we've got stores, right? So we want to find these pancake ingredients, which are flour, eggs, milk, syrup. We can see right here, pancake ingredients, flour, eggs, milk, syrup. So we want to access this object, this array, that's inside of the stores hash. So we can call stores. We've got that, cool. We can see the desired target right here, so that's inside of the stores Denny's object. So we can access that with stores Denny's, or we can do that. But you can also call stores.keys, and that'll show you like the top level keys. So if you do like stores Denny's.keys, now you can see the keys one level down. So this will be useful later, but just know like .keys is cool. So stores Denny's gets us close to where we want to go. So let's add on, we want that dishes key, right? We saw that employees and dishes were options, so we'll do dishes, and there we go. We're getting close, but this is an array. You can see it's wrapped in these brackets, and we can call .class on it. So the array is not what we want. We want the actual list of ingredients, but we can't just call stores Denny's dishes and then like name, because that's not an array method. That's a hash method. So we could say dishes.first, and that would get us that particular hash object. And then we could pop on like name and get back the name. Or we could call .keys again and see what we've got, that stuff. Or we could just pop in ingredients, which is, I believe, our target answer. So cool. We built this up in Pry, so we can just copy and paste that right down into here. Take out the Pry, and we'll run our tests. Should pass. Cool. 2 passes and a skip. Many skips. All right. Test risotto price. So risotto price equals. Let's see if we can do this in one fell swoop without a pry this time, because we know how we can access the keys and the values. So first, risotto price. Let's see where risotto price is. We might need to bring that up. Risotto. There we go. So this is probably gonna be stores, key Olive Garden, key dishes, first, key name. Here we go. Stores, Olive Garden, dishes, which we know that this is now an array because there's a collection of dishes in here. So .first, now we're back into hash, so we can call price. This should do it. Cool, 3 dots. We did 2. All right. Test Big Mac ingredients. Take that off, take that off. This is going to be pretty similar to the pancake ingredients, right? So we already know it's going to be stores.something, and Big Mac, risotto, name, pancakes, waffles, Big Mac. Here we go. So McDonald's, of course. Oh yeah, that is the McDonald's signature dish. McDonald's. Dishes. First. Let's drop this in a pry. Maybe something exciting will happen as we explore around. Binding. So we've got stores, McDonald's. Cool, getting closer. Big Mac is in there. Dishes, Big Mac is even closer. .class, this is an array. So we could say dishes 0. We could also do, I think we can do, how would we find, why would we do find? Enumerator. Okay, .find, maybe we could pass in name. Name, this probably isn't going to work. Name Big Mac. And that's an empty enumerator. If you call like inspect on this, it'll show that it's, oh, it did work. Cool. Dot 2s. Maybe we can p it. Interesting. So it's grabbing the thing that we want, but it's not really letting us show it. So let's see. Okay. So we've got brought over a browser tab. I want to know how this find method is working. So we're just going to do Ruby. That was on an array find. Ruby docs. It's always good. Array is going to be a method over here. I'm just going to control F for it. Ooh, that's going to take a long time. Is it in here? There we go. Oh, find index. Oh, enumerator. This is an enumerator method. So that'll be Ruby enumerator find. It's a different method. Module enumerable and find. Passes each entry in enum to block, returns the first one for which block is not false. So dot find, and we can pass in a block. Interesting. I wonder how we then access the objects in that. Dot first. Okay. Big Mac dot first should return that Big Mac object. Cool. This was a digression. We might use this later. Just know that you can use dot find. It's an enumerable method inside of hashes. And then we could still get ingredients. So we'll use this. Stores McDonald's dishes dot find name Big Mac dot first ingredients. I don't like this method. I don't like this, but it's useful for exposing us to like new methods. So let's see if this works. Cool, passes. Guarantee some of you found better ways to do this than using find. I don't want to rely on knowing the index of something, so that's why I used find. Like, what if there was 100 dishes in here and their order was random, right? Like, we couldn't rely on just pulling out the first, so I didn't want to. Then the dot first is just popping off the found item. Then ingredients. Okay. So store name equals your code here. So test lists of restaurants. Okay, here we go. Now we're doing some interesting stuff. Let's run the test. So we want to get a collection of keys. Stores is that. Remember we did earlier stores.keys? That looks suspiciously accurate. Olive Garden, Denny's, McDonald's, Olive Garden, Denny's. All right. Stores.keys. Get out of there, run the tests, and we pass. Dish names for Olive Garden. Finding again. This is probably going to be the same as calling .keys on something, but just one level deeper in the stores object. So we want stores, Olive Garden. We want risotto and steak. So Olive Garden dishes, right? Interesting. We want to get just a single attribute from each of these. So we could do like a one-liner. We could do like dot map. This would be dish name. We'll unpack this in a moment if this works. Risotto and steak. Cool. So let's unpack that. So we've got stores, Olive Garden, dishes, dot map do, and then this is going to be dish object. So then we'll pop in an end, and we'll move our pry down to there. So we're going to get out of this and hit that pry, so we can see what our dish is. Yeah. dish, not dish. So we could say dish.name, dish key name, and that gives us the object that we want, and we're calling .map. Well, they said this could be done. Some tests will pass. So use .each. Let's use .each then. I apologize, author of this, for using .map. We'll do .each. And we know that we can access like each of these dish objects has that risotto thing. So I can hit continue, and I'm going to hit this pry again in a moment with a different dish. I had risotto a moment ago. You can see me pointing there. Now we have steak. So we could call dish name and get steak. So we want to kind of squeeze those two together. So if we hit continue, so what did we have? We had dish name, right? So this is gonna, each isn't gonna work. So we could say dishes names, because each always returns the value, the array that was gone, that it's iterating through. So if we do like, open up quick pry session, if we do 1, 2, 3 dot each do dot each number and like do num times 2, yeah, that's gonna work. It returns the original array. But if we do .map, it returns the mutated array. So if I wanted to say like new thing equals 1, 2, 3 dot each num times, let's make it 50. This isn't going to work because each always returns the array that goes into it. So new thing is no different than the old thing. But if we swap this out to map returns the new array. So now the new thing is very different from the input array. So usually when you have to use each, you have to set up a collector outside of the each. So we'll do that. We're going to do dishes names equals empty array. And then we'll just do stores.each, and we'll shovel in dishes names, shovel in the dish name. And now dishes names will collect that. We'll refactor this in a moment. So let's make sure that works. Cool, so it passed. So just to like reiterate, the instructions say complete all using each and then refactor, but we'll just refactor this one real quick. So we're going to get rid of that, or we're going to do dish names equals, and then we'll say map, because that changes the value, or that doesn't return the input array. Map just returns whatever is evaluated inside of the block. So this will still pass. Cool. The difference between dishes and each, map and each are important, and just know if you are trying to iterate through something and getting the input array, you're probably using each. Onward. Employee names equals. We want all employee names. Here we go. This is going to be fun. So let's run that and hit the pry. So we want all employees. So we know we've got stores dot. Yeah. So we're just going to immediately reach for an iterator. We'll put employee names equal to this, and then stores dot. I guess each. Do store, and we'll put pry in there. Stores.each do store. We'll try this. So we've got stores as our big hash, but now we have store. It's going to be equal to that first one. So store Olive Garden. So we could do store.keys. Nope, store.keys for array. Store is an array. Interesting. Store is an array. That wasn't what I expected. stores.first.class is an array. Okay. Maybe each. I guess that kind of converts it into an array. I'm not 100% sure. So we've got store, which is an array. So store.first. So Olive Garden stores oneth is that. Store.last is that. Store.find, we're going to try this. Dishes. First, did that work? No. Olive Garden. Olive Garden employees. Store.find dishes. This is confusing. Let's see. So store, we're going to look up the Ruby docs for enumerable. Let's see. We want to do hash and then each. So classes should be hash in here. There we go. And then let's find the each method. Okay. Some of these seem promising. So each key value block. Okay. Hash.each key value, key is value. So that gives you access to the key and the value. Then each key, each pair. Kind of funny that these are all the same instructions. H.each key. There's still no instance of each pair. Let's modify this and make it take key value. So stores.each kv, and then we'll see what k and v are equal to. So k is Olive Garden and v is the rest. So v employees. Cool, that's our employees. So let's say, this is kind of cheap. I don't like it. But this is gonna find our employees, and we'll do employee names, shovel in v employees. I think that's not gonna work. I think that's gonna make an array of arrays. So let's see. Yeah. So we get the right name. See, Jeff, Zach, Samantha, Samantha, but these are wrapped in arrays that we don't want. We want them all together. So we could call .join on them, or something. We could, like, well, here, I'll show you. So we'll put another pry there. So we'll have our collection of employee names. You could call .join on them, right? Not like that. So that joins them as a string. So that's not what we want. This is a collection of strings in an array. So we could try employee names.flatten, and that makes it work. But we could also do something easier. If you just call .concat and then pass in an argument, it let's see, it'll work. We want array, Ruby array concat. Here we go, API docs. Append the elements of other array plus s to self. That should be obvious. Just kidding. So this example shows if you do concat and pass in something that is an array, it strips out the array. So that'll be good enough for our purposes. Continue. We'll run it again, and it passes. So cool. And again, we'll do this. Now we'll refactor out the each and make it a map. This might not work as planned. Equals stores.map. We're gonna, no, we don't need to deal with that stuff. Yeah, so now we have the same problem. So we can just call .flatten on the end. This is my cheap and dirty way to just keep us moving. And it works. If you didn't know you can do that, you can. If you have a multi-line block that puts out an array, you can add .whatever to the array method. This is not great code, but it works, so we'll carry onwards. List all of ingredients across all restaurants. I suspect this is gonna be pretty close to what we just did. So we already know we're gonna be iterating through stuff, so we're gonna do stores dot do output equals that, stores dot each. What was some of the other methods that we could call? I want to try something else. Hash each key. It's key each pair. So we'll try that. Each pair. This looks very the same as key. Each pair do key value and binding key. It's Olive Garden value. So let's change this. They say naming is hard, so let's do better names. So we're gonna say store name. We'll do store because that's the key, and then we'll say data. So now it's gonna make a little bit more sense. So we want to access our data. Great. And then we want ingredients. So we'll do like data dishes. Cool. We could do ingredients. I fell for that problem. Dot each. Well, so this is an array, right? So we need to figure out how to access the ingredients object from each one. We know that we can do find, so we'll try that. We'll pass in ingredients. Maybe that'll work. Enumerator. Man, this is tricky. I've not dealt with enumerators a lot before. At least as a result of using find inside of a hash. The active record is a whole nother story, but where did we have our enumerator? Let's just go up here, classes, and I know that this is that because it says it's an enumerator right there. Enumerator. What methods? Each feed inspect. Prints a printable version of enumerable. So we should be able to call, oh, this is a useful little thing you can do in pry. You can do, like, I want to say I've got this temp variable equals underscore, and that sets temp equal to the last returned value. So if I have, like, crazy string, and I want to say crazy string is equal to that, I can just do crazy string equals underscore. Last evaluated thing, it's now crazy string. So it's useful. So we've got this temp, which is an enumerator. So temp.inspect puts out a printable version of it. So I wonder if we can access enumerable. That's still an array. That didn't give me anything. Maybe temp.next. Interesting. Enumerables. I want to like just roll through it and pull out all of the values of something. So enumerable. Interesting. Peak. So we could iterate through each of these. We could say store data, data, what did we decide this was? Data dishes, returns that, and then we can just do dot each. So now we're iterating through this enumerable. Do dish, and we're gonna put our binding dot pry there. exit out of that, run it again, hit the pry. So now we've got this dish available to us here. So we can say dish ingredients, and those come back. So we can then just shovel output dot concat dish ingredients, and then we can set, what are we dealing with as our output ingredients. So we're just going to take that away, call this ingredients, and then shovel into there. And it works. Okay. It's kind of weird, kind of hacky. Don't love it, but the point of this exercise is get better with hashes, and these are the things that will get us better with hashes. So no sweat. We didn't use each, even though this will probably work the same with each. Yeah. Let's see if we can make it work. Let's see if we can make it work with a map. So ingredients equals, so we don't need that, stores dot map, and then this should put out, so this will be an array of arrays, like the thing that we had above. Yep, rice, cheese, whatever, and we actually got, oh, we did not get that. Dish ingredients. I'm not going to worry about it. We're just going to leave it for now. So pass. Cool. If there's interest in a refactor, we'll cross that bridge when we get there. Full menu price for Olive Garden, 27, full menu price. So we're going to do, uncomment that, say full menu price equals 0, and then do stores dot each do store data and binding.pry, and let's hit that. So it's going to be similar in concept to what we dealt with just above. So we've got data, and we want to get the price, so probably 12 plus 15 equals what we want, 27, that seems right. So data dishes, right? Dishes. I wonder if, dot find. If we pass in no arguments, it comes up with that. Dot 2s dot inspect. There, I want to be able to. There should be this dot maybe reduce, and we can do, and this isn't gonna work. Price for hash. I know that there's a way to get the price out of the state of each do. We could do like so now we're in a dish, and then we'll say dish. That needs to be closed. That's returning the input array, so if we did map, it'll come out with that. So that's gonna kind of work. And then instead of just getting dish price, we can say full menu price plus equals dish price. And this could then be an each now. So that'll, get me out of here. Expected 27, actual 51. All right, so let's make this a multi-line block. because that makes it a lot easier to deal with. Stick a pry in there, and then we'll see what we got. So dish price. So why did that not work? Test full menu. Oh, for Olive Garden. So that was everything. I guess we could just do stores and then pass in the Olive Garden key. And then now we could also just pass in dishes. Because now we're here. This is now an array, so we can take this away. We'll say we're dealing now with a dish. And this will still work. So we kind of like hacked this together. If you want to indent and outdent lines, if you highlight the line and go left and right with like open square bracket that goes out and in, you can also, this is kind of cool, it like retains indentation. So where are we? Right here. So we'll just give this an example. If you go out or in of multiple lines, it just keeps all the indentation in the right place. So store, where were we? We were right here. So we've got stores, Olive Garden, dishes, dot each. So that's stores, Olive Garden, dishes, dot each. And we're iterating through this. And then we just call dish price. So this, each one of these would be set equal to dish, and when we call price, we're getting this value on it. So you can do full menu price plus equals dish price. Should work. Cool, it worked. I wonder if we could get away. We could get away from each, but we can't use a map. Let's do reduce. Reduce is a lot of fun, and it's a lot of work the first time. So full menu price equals stores, whatever dishes, dot reduce. Reduce takes an argument, and this is going to be the input argument. So if we do like foo, that's going to be our input string, and then it has two arguments that you have to give it. It's going to be a collection, so a lot of like that'll be modified each time you roll through it, and then there'll be the actual value. So we'll do collection dish. Let's put a binding in here. This is going to be great. If you haven't used reduce yet, it's a good tool. Anytime I see each like in the world, I'm like, oh, maybe there should be a reduce. Or anytime you see like a collector outside of something, it could usually be a reduce. So we've got, make this a little bigger, this collection and dish. So let's see what collection is. And that's, so collection is set to the value of whatever is passed in as the first argument of reduce. And then dish is our iterable. So we could do collection plus equals 1, probably not, as a string. Oh, that worked, okay. So we could just keep doing this, and it keeps appending 1 to the end of the string. And then when we hit continue, it'll hit it again. Plus, okay, for nil class. So it doesn't like full menu price because that doesn't exist. So we'll do menu price. So we can do, so this is gonna, an inject or reduce, their alias, they're the same thing, always returns a value, and the return value is what like full menu price will be set to. So this full menu price is actually, like this was our collector earlier, so we're just going to say collection plus equals dish price, and we're going to start with our collection equal to 0, right? That's a reasonable starting value. So if you do collection plus equals dish price, this is not going to work yet, but we'll get there. This took me a really long time to fully wrap my head around how like reduces worked and different things were passed around. So I'm rolling through it really quickly now. Hold on to as much of it as you can, and then a couple rounds of reducing, you'll be in good shape. So collection is going to be equal to 0, right? Because that's what we started it as. So you could do collection plus equals dish price, and now we're at 12, and we can keep bumping that. But now let's hit continue. And we're going to hit our pry again because it finished that first iteration, and then now we're on to the second one. So dish is now our second object. Earlier it was like steak, or steak. Earlier it was risotto, and now it's steak. But what do you think collection is, right? Like earlier, collection was 48. So let's see what collection is. 60. Excellent. That was not what I expected. I expected it to... we'll let it go. There are... Never mind. We'll cover that in a minute. So we're just going to continue out of there. Take that away. Let's try that again. Ba-boom. It's working. So this is using a reduce. We could have also iterated, like we could have figured out a way to do this, like stores.reduce. Start with 0 collection, and then this would be like store, and then we'd have to build up like store dishes, dishes, ingredient, whatever. But this is gonna do the trick. So, full menu for Olive Garden. Your code here. So we could do this the same way. Let's use... We'll just solve this the simplest way possible first. So we're going to do stores.each. Well, we know we want stores Olive Garden, so we'll do stores Olive Garden dot each do and that's going to be store and data. And because each needs a collector outside, we're going to say Olive Garden menu. So we want Olive Garden menu to be equal to expected Olive Garden menu to be equal to this thing. So we're going to start Olive Garden menu as a hash. So it makes sense in a minute. So we're iterating through stores, Olive Garden, each do store data. Why is that unhappy? Require pry, binding pry. Oh, that's the wrong character. Okay. So we'll hit this pry. I'm going to shorten Olive Garden menu to OGM just because it's going to be hard to type otherwise. And then we can set that equal to OGM. So OGM equals that. So store is equal to, oh, that wasn't expected. Data is everything else. Oh, interesting. So what do we want? We want ingredients. Let's do Olive Garden dishes dot each do. Dishes will be this, and so this will be iterating through just a, this is going to be an array object, so we'll just do dish. Get out of that. Symbol into integer, that wasn't happy. I'm going to exit out of that and try that one more time. Okay. Try Rails failed. Whatever. So we've got OGM, which is my empty hash, and then dish, which is this thing. So we want, I know this is going to be a bit of a tricky one, so we want we basically want this to come out of a dish, which looks a lot like what's going into a dish, right? So I'm going to set this temporarily as an expected variable. So we're going to do like expect equals and then paste that in just so I can play with it a little bit. So we've got expect, we'll have to add one more there, I think. Yeah, so expect equals that. So this is not the same format earlier, right? Like, so we can't call expect name, like that's a non-existing key, but we can call expect risotto, and that's how we access the rest of the hash. So this is a key. It's a key that's a string, but it's still the key. So we want to figure out how to like build the key that is a string and then pop everything else in there. So let's see. So we've got OGM. We can do, so hashes and creating new hash values is like a whole thing in and of itself. This video is already really long, so we're not going to worry too much about that. But just know that you can set keys like so. Like expect.keys is, well, that's expected. OGM.keys is going to be empty. You can do like OGM, I'm a key equals me too, and now OGM has this key and a value associated with it. What you can't do is OGM I'm not a key. This key doesn't exist, and if you call it, it just returns nil, and OGM isn't mutated by it. So it has to be equals like something. But that means we can do OGM, and let's see, where am I? In Pry, you can do where am I, and it just reprints the block of code that you're stuck in. So we've got dish as a variable. So I can do dish name, like that, and that's the key that we want. So we can do OGM, and then pass in the thing that evaluates to the string of the key that we want, which in this case is dish name. Close that out. Of course, that's not going to work, so we need to set it to a value. So we're going to say equals empty string. And let's take a look at OGM, and boom, here's a key that we want. So let's clear OGM. We're just going to set it equal to empty hash, and then pull this back. OGM dish name equals, but we don't want it to equal an empty string. We want it to equal this key value pair. So I wonder if we could just call dish and have that work. So OGM dish, so here's the key, so that means OGM risotto is now a key available to us, and that returns name risotto ingredients, rice, cheese, butter, price 12. Name risotto ingredients, rice, cheese, butter, price 12. Cool, so that looks promising, right? So let's do this. So we'll do OGM dish key equals dish, and that should build up the output array. We'll just leave the pry there, rerun this, and try it again. So OGM should be mutated by now, so let's take a look. Nil, name, risotto, ingredients, rice, cheese, butter, price. That's not exciting. That's not what we wanted. Dish key. Oh, dish key isn't anything. Dish name is what we wanted. So let's change this to the right thing. So dish name equals dish. Now we'll rerun this. Take a look at OGM. That looks promising. Take the pry out. Expected that. OGM, let's see if it works. No. Test line 107. 107? Oh, this last test broke. No implicit conversion of symbol. Okay, well, quick note. This test worked. This passed, so now we're going to go fix this thing real quick. Stores.reduce, collection dish, collection plus equals dish, full menu price, and it's saying implicit conversion of symbol into integer. So what do? We stick pry there, and then we see what symbol we're trying to call or convert into an integer. So collection looks right. Dish, dish is wrong. Oh, this was stores Olive Garden. So it was breaking because dish doesn't have an attribute of price in this. Collection dish. Stores Olive Garden. This also needs to be dishes. Dot reduce. Now we're good to go. Cool. Apologize for that. I was over ambitious with the Control-Z button earlier. All right, so full menu for Olive Garden, test menu across all restaurants. It's going to be a doozy. So full menu equals, we're going to do the same kind of thing as before, instantiating an empty hash, and then we're going to call stores.each do key store data. And let's start building it up. So there's test menu across all restaurants. So we want store. Store is just going to be our key. Data is going to be the good stuff. So we want data. Oh, I should have probably made this dishes because we just need to go straight to dishes. So let's do that. Stores. Oh no. Stores.each do store data. Yeah, we'll just do data dishes. We'll do a double enumerable because data dishes is an array, right? Call class, there's an array. So we'll just iterate through again. Each do dish. And let's bump our pry up, run it again. So now we've got this dish object down here, and this is basically going to be the same thing that we did before, right? We'll do full menu is that. We'll give it a key of dish name equals dish. Forgot the closing bracket. Full menu dish name equals dish. Didn't like that. Full menu dish. There we go. Nope, we did want dish name equals maybe a close that, and then that equals dish. So let's see, full menu. What am I doing wrong here? Full menu. So dish name. Data dishes each do dish. Name ingredients. This is weird. I'm gonna exit the pry and just hit it again. I expected dish to be a dish, just like one of those, like same as what we've worked with before. So let's see. We've got data dishes that each do dish. So dish should be the first one of those. Cool. Dish name. Maybe when I was manipulating the hash earlier, I kind of like overwrote the temporary dish variable. So we want full menu with the key of dish name, close that out twice, to equal the dish attribute. So full menu, risotto, name, risotto, ingredients, blah, blah, blah. Name, risotto, ingredients, rice, cheese. Okay, I think that's going to work. Cool. Passed. Do we want to refactor this? Let's try to make this a reduce. Reduce, and we can pass in an empty hash because we know that's a thing. So that means that this is going to be a results output, so we can call it results. And then stores.reduce is going to iterate through, so we're going to say store with data. And let's go from there. Put a pry there, and then we'll just see what store with data is. Store with data. Cool. Then dishes. Oh. Store with data. What do we got? Keys. Oh, it's an array. This is okay. I wonder if we can pass this is going to be an exciting option. We're going to do store. We're going to do 3 arguments. I don't think this is going to work. But remember, like one of the earlier methods, it would take like an each with a key value pair. It'd be pretty cool if that worked here. Store data is nothing. Okay, so that doesn't help us. So we'll go back to store with data. Exit. So exit like releases the pry, triple exclamation marks or bang bang bang, like forces you out of the pry and doesn't let the program continue. So I'm used to hitting exit, so if I had like a test running, that would continue. But then eventually, sometimes you just have to force quit out of it. So store with data is an array. So let's say, so 0 is going to be Olive Garden, 1 is going to be that. That's what the class is. That should be a hash. So store with data. I don't like just arbitrarily calling indexes on arrays, but we'll work with that. So that will give us dishes. Store with data dishes. So we're going to say store with data 1 dishes. I'm going to exit out of this now and hit it in the pry again. So we've got our results, which is empty still. And then store with data dishes. So we could say dishes equals that. So this is going to give us kind of a smaller interstitial handle to grab some of that data, and it'll be a little easier to work with. So dishes is now this smaller array. And we could do a second reduce, I think. I don't know if this is going to work, but we could do, let's not go too crazy. So we've got this results array. So we're going to set, I think, let's see, results, foo equals bar. Okay, so results will continue. So we'll just do results, dishes. We're going to have to iterate through this thing. Dot. Dishes dot each do dish. Oh, this is so bad, but it's going to be great. And there, and then all of that. We're going to bump the pry up one more time. I know someone out there is going to find like a massively better way of doing this, so when that is you, please let me know what it is. This is not beautiful. So we'll do results dish dish name equals dish. Yep, so results now has that thing. So results dish name equals dish. And we're gonna, there's got to be a map because otherwise the this isn't gonna come out. And then we're gonna say results equals dishes.map. So I don't know if this is gonna work. Maybe I'll just end up deleting this whole portion of the video because it's not gonna work. All right, definitely didn't like that. String an integer 131 right here. So let's try binding.pry and see what went wrong. If nothing else, you should be learning quick workflow between pry and the code that you're working on. So dish name is what we called it. So results dish name results. Yeah, okay, so I'm gonna continue this. Results is still like empty. We're gonna play line 132. So that lets the next line evaluate. And then now the results array has been mutated. So let's call results. That looks like what we want. So I'm going to type continue, and that's going to release the pry. And we'll hit it again. So dish should now be different. Before it was risotto, now it's steak. We're going to play -L132. So this is how you can like get inside of an enumerable and watch it unfold. So let's see our results array. So risotto name, steak name, this is looking good. Continue, play line 132, because it's broke somewhere. Ah, okay, so that's where it broke. So what is dish here? What is results? So this dish is pancakes. Why did that not work? Nope. Implicit conversion of string into integer. Price, this kind of all looks the same. Results is still there. Results is now an array. So results, so this is dish. So let's see, dish name is what we're trying to pass in there. So I bet results pancakes will definitely, yep. Why did this turn into an array? So this is what I was going to try to get at earlier with the results, is sometimes it's useful to pass out, well, hold on, before I say go too far down this, let's just see if this works. So result dishes.mat. Let's flop this to an each. Dot each do dish. I don't think this is going to work. If I get this working, I'll explain why. Variable full menu. What is full menu? Oh, so we want full menu to equal this. So full menu equals stores.reduce. Cool. Okay, what just happened? One, I knew that we could do this with a reduce, but not elegantly, not beautifully, and it's going to be a little bit confusing. So results here, the problem was when you're using a reduce, we've got these two variables, right? Results and store with data. Results is really tricky the first time you go through it. So first, know that results is set to whatever the input argument is to reduce. So in this case, results was this empty hash. Now, results is always set to, like when you go through the block, whatever the last line is that's evaluated is what results is set to. So we've got results here. If I put a random string and then stick that pry there, let's see what happens. So we've got results, right? Looks normal. We're going to continue. So now results, like we would expect results to be the result of this hash, like creating this new hash. But let's see what we got. Results. Oh, each do dish. Okay, so we're gonna continue again. Results, each do dish. There we go. So once we got out of this inner block of code, the last line evaluated when this reduce like grabs the next item off of the array, the store object, and goes through it again, it sets results to this last, to whatever the last method is. So if we add results here, this is going to work because this gets evaluated, nothing happens, and then results that is the last object to come out of the array. It gets set as the input array, and then everything continues. So if I take this pry out, well, let's see, if I leave that in, well, now it's not going to work because not worth it. But if we do results here, should be good to go. Cool. So like I said, reduce is complex, but once you get through it a couple times, you should be good to go. Also, from a complexity perspective, I didn't figure out all of these pieces of how reduce work together until like the end of mod 1 or maybe even like mod 2. So if you haven't started Turing yet, don't sweat it. Just know that like the arguments of reduce matters. Actually, let's check the docs. Ruby reduce. That's an enumerable. Here we go. So initial combines all elements of this. If you specify a block, none of these are like really great examples. Just know reduce is complex, but it does a lot of stuff. Okay, that was the end of this. All of the tests pass, so we're leaving it there. Hope this was helpful. When you find better ways of building some of these, or if you're the person that created all of this, actually, let's see who made this. So I just copied and pasted that. We're going to do git blame, which is super useful. Pass in the test, or pass in the file name, and this shows the git history of everyone that's like made this stuff. So the instructions were written by Brian Zanti or Zachary Thomas. So if you, Brian Zanti or Zachary Thomas, want me to update any of this or think I did it wrong, let us know. Okay, we're calling it.